pick up from where we just left off, and we're going to look to model some data using linear equations to help us out here. A speeding ticket is $100 plus $5 for every 1 mile per hour over the speed limit. Write a linear equation to model the cost, S of x, in dollars, of the speeding ticket for a person caught driving X miles per hour over the speed limit. Because we have a changing, a variable increase here based on how many miles an hour over the speed limit here, and we're going to look at X miles an hour, we know it's $5 for each one of those. So our function, S of x, for speeding, is going to be $5 for every $1 over the speed limit, so that's X miles per hour over the speed limit. So that's going to be 5x plus there is a base cost for the ticket of $100. And you can see that this is in slope-intercept form, where our slope is the cost for every mile per hour over the speed limit, and this is our base cost here for the speeding ticket of $100. Now, we're going to use this to evaluate S of 15, and we're going to try to interpret what this means with respect to the problem. So, S of 15 means I'm plugging 15 into here, so that's 5 times 15 plus 100, which is 75 plus 100, which is 175. So what this means here is that the speeding ticket will cost $175 because they were 15 miles per hour over the speed limit. If the speed limit at that place was, let's say, 45, they were doing 60. And they got a ticket that's going to remind them to slow down. Another application has to do with more of a business aspect of cost, revenue, and profit. And we're going to be able to write all three of these topics here, cost, revenue, and profit, in terms of a linear equation. Now, cost, linear cost function models the cost, C of x, to produce X items. So I have a company and we're going to make widgets, and I'm going to produce X widgets. I'm going to be able to write this, notice the slope-intercept form, C of x equals mx plus b, where m, the slope, is the variable cost per item. So if it costs me $10 to make a widget, m is going to be 10. And b are going to be my fixed cost. That might be the cost of running the factory, or insurance, something that's fixed that's going to be the same all the way through. Linear, and that's cost. Revenue, now revenue is money from sales. Linear revenue function models the revenue R of x for selling X items. So R of x is equal to P times X here, where P is the price of producing the item. So if it cost, let's say, or price per item producing, excuse me, the price, not the cost. If P is the price, maybe I sell a widget for $15. Then P would be 15, because for each widget I produce, 15 times that amount. Linear profit, the linear profit function, excuse me, models the profit of producing and selling X items. So I have my sales, I have my cost. Revenue minus cost is going to give me profit. Now hopefully this is going to be a positive number, because if this turns out to be a negative number, if my cost is too much, then I'm going to end up owing money and I'm not going to have any profit at all.